Hi guys, welcome back. In this lecture, I want to talk about how to solve roots using the Moivres theorem. Okay, so before I get into that, I want to talk about some of the more interesting features in the polar forms. Okay, so for example, if I have z is equals to 3 plus 4i, 3 plus 4i. Okay, now by now you should be able to convert that into the polar form of z is equals to 5 cis and then 0.927 radians. Okay, now um, if we are to draw this onto the argon diagram, okay, so that's my real axis, that's my imaginary axis, and if I draw a line here where this is 4, this is 3, okay, this is where my complex number lies, okay, and this is my theta, right? Now if you can imagine that this line here can rotate 2 pi degrees, okay, so if it rotates 2 pi degrees, then that means that I will arrive at the same position at the same dot, right? So we need to, so there are multiple or actually infinite amount of solution or ways that we can express 3 plus 4i in the polar form, yeah? So our equivalent solution for this would be we simply just add 2k pi in the cis function. So we should actually add 2k pi at the end. So 5 cis 0.927 plus 2k pi, where k is the number of rotations. Okay, so say for example, if I rotate this once, then that means k is equals to 1. So z is equals to 5 cis 0.927 plus 2 pi, plus 2 pi. That will give me back exactly 3 plus 4i. Okay, so how do we use this information to solve for the cubic roots? Well, not cubic roots, but for any other roots. Okay, so let me propose a question. If z to the 5 is equals to 3 plus 4i, okay, then find the five roots in rectangular form. Okay, now this this question is just the same as asking you, okay, if z to the power of 3 is equals to 8, what is x? Okay, so x will have three numbers, okay, so 1, 2 and 3. So for this question, z to the power of 5 is equals to 3 plus 4i, find the 5 roots. You're basically finding the the 5 factors, yeah, for this one. That if you multiply all of them back together, you would get 3 plus 4i again. Okay, so coming back to the x, that will be 2, 2 and 2. Okay, so our first step that we need to do is that we have to convert uh, this 3 plus 4i into polar form, yeah, so that will be 3 plus 4i, and that is equals to 5 cis pi 0.927. Okay, but remember our equivalent solution, so that will be plus 2k pi. Okay, now to get rid of the fifth power, we have to get that to the other side. So 5 cis 0.927 plus 2k pi raise that everything to the power of 1 over 5. Okay, so from the Moivres theorem, there would be 5 1 to the 1/5 cis 0.927 plus 2k pi over 5. Okay, now the function of k in this is that we have to iterate from k equals to 0 to k equals 1, k equals 2, k equals 3, k equals 4 to get our 5 factors, to get our 5 roots, right? So we have to iterate that from 0 to 4. So my first solution would be k equals to 0 and z1 is equals to 5 1 over 5 cis 0.927 divided by 5. Okay, k2, oh sorry, k1 is equals to z2 is equals to 5 to the power of 1 over 5 cis 0.927 plus 2 pi over 3 over 5. So k equals to 2, that would be z3 equals to 5 to the power of 1 over 5 cis 0.927 plus 4 pi over 5. Now let's do the rest. K equals 3 and k equals 4. So k equals 3, that makes z to the power z to the 4 equals to 5 1 over 5 cis 0.927 plus 6 pi over 5. And then the last one, k equals to 4, that makes z the fifth z is equals to 5 1 over 5 cis 0.927 plus 8 pi over 5. Okay, so what that means is that let's just recap for a bit. Our question was z to the 5 is equals to 3 plus 4i. Find the roots. Okay, I will have 5 roots, right? So z is first root, second root, third root, fourth root, fifth root. Okay, and each of these, and how to get each of these is to iterate k. So I have to iterate k from 0, k from k equals to 1, k equals to 2, k equals to 3, and k equals to 4. Okay, remember that k equals 0 is still a root. It will still generate a root. Okay, so when k equals to 0, that's my first root, second root, third root, fourth root, fifth root. Okay, now I've done the rectangular form already. So z1 is equals to 1.36 plus 0.25i. z2 is equals to 0.18 plus 1.737i. z3 is equals to negative 1.25 plus 0.59i. z4 is equals to negative 0.94 minus 1.00i, and then the last one, z to the 5 is equals to 0.66 minus 1.21i. Okay, so this is my roots in polar form. So I've answered the question in here. Okay, now one cool little feature about this is that if you want to draw that on the Argand diagram, right? If you want to draw this on the Argand diagram, let's make this more straight. Oh, that's better. Yeah, if you want to all draw this onto the Argand diagram, now I'm just going to approximate. Okay, so the first one should be somewhere around here. So that's Z1. Z2 should be somewhere around here. Z2. And then Z3 should be somewhere around here probably, Z3. Z4 should be somewhere around here, and then Z5 should be somewhere around here. Z4, Z5. Okay, now that should be, Z1 should be a little bit further, so that should be around here. Okay, so now what that means is, if you were to connect the complex number to the origin, yeah, these will all have the same angle between. Okay, so this angle and this angle and this angle, this angle and this angle, they're all the same. So that means that they're spread out by 360 over 5. So each angle is 360 divided by 5 degrees apart, and they're spread evenly spread. Okay, so that's a one cool little feature about the Moivres theorem. Okay, is that the roots are evenly spread out onto the Argand diagram. Okay, now just let me recap on the procedure about this type of question. Let's do the whole thing from the beginning. So equivalent solution. Okay, now equivalent solution, the reason why we have equivalent solution is that once we convert rectangular form complex number to the polar form, each rotation of 2 pi will give me exactly the same spot, will give me exactly the same z, which is in here, which is this part here. Okay, so therefore we have to express our polar form in the equivalent solution, which that means that we have to add 2k pi. Okay, so k is the number of rotations. Okay, now suppose that I have a question, if z to the power of 5 is equals to 3 plus 4i, find the 5 roots in rectangular form. Okay, so this question is just kind of like saying, well, okay, if x to the power of 3 is 8, what is x? So x is 2, 2, 2. x1, x2, x3, they're all equals to 2. Okay, so similarly, x to the power of 5, you need to find the 5 roots. Okay, and to do that, we have to iterate the k in the polar form from 0 to 4. Okay, from 0 to 4. So that will be k equals to 0, k equals to 1, k equals to 2, k equals to 3, and k equals to 4. Okay, and so our first step that we need to do is that we have to draw the Argand diagram, draw 3 plus 4i onto the Argand diagram, and then obtain the polar form, and then plus 2k pi after that. Okay, plus 2k pi after that. Next, we have to get rid of the fifth power by raising the right hand side to the 1 over 5, one to the power of 1 over 5, which is that. And from the Moivres theorem, we obtained this equation here. Okay, keep in mind, dividing by 5 means that everything on the top is divided by 5. Okay, so this whole thing is divided by whatever the powers that is raised to. Okay, and we iterate from k equals to 0 all the way down to k equals to 4. Okay, and we obtained the rectangular form here. We have obtained the rectangular form, and that is our solution. So if we multiply all of these together, I'll get back the same thing. So which is z5 is equals to 3 plus 4i. Okay, now again, one cool little feature about this is that all the roots are spread out evenly across the Argand diagram. Okay, so this can be like a a cool trick that you can use or to check your answers in the exams if you're not confident. Okay, so I hope you guys understand, and if you have any questions at all, please feel free to drop me a message on the discussion board, and I'll get back to you as soon as possible. Okay, I'll see you guys in the next lecture.